Hello, today I'm going to talk about the system design for message queues. And the message queue is a pretty common component which may be used during designing of other systems, but I'm going to talk about how to make a message queue as a component and system itself. So some topics would include clarifying questions and requirements, high-level components, case for simple in-memory queues, some Redis pub sub, and finally about brokers for like more complex message systems. Some clarifying questions. It's like, for example, how are queues being read and written to? Like, what are the common patterns? Is there like a bursty pattern or like a regular like workload? Do we have like one publisher or multiple publishers for a queue? How many subscribers do we have? And then how long the message can be stored. Is it like very short-lived or like can it be stored for days? Should the message delivery be at least once, at most once, or exactly once? First two are generally like not as difficult, but the last one is very tough. Another one is what's the business use case? Like, is it like for some logs where we probably can do at most once? Payments where we need exactly once, or something like alerts where we can do at least once, but not like go overboard with it. What is the expected latency and throughput? And all of this is pretty important to determine how complex the system should be, and also what storages can be acceptable. So let's talk about three possible designs. One is just use simple in-memory queues. So we have one or multiple publishers right into the service, and then service stores queue in memory and just like has some synchronized queue, or just uses some regular queue plus lock. And it may have some disk backup or object storage backup. Restoration like can be slow, but if it's like for short-lived things, then it can be like relatively fast. Object storage is generally better because if node goes down, then like disk may go down with it. Or you may want to use something like EBS storage for AWS or similar. And then there can be like ideal case when there is one subscriber, possible with multiple instances, but once we read a message, it gets deleted from the queue. Similar to this is Redis pub sub. Redis actually provides this like model where you can create some channels with names, and then publishers can publish to the channels, and then like whoever subscribed to the channel gets a message, and message gets deleted. Again, good for at most once delivery and for like high throughput, but not good if you want like it maybe exactly once or want like some historical data. And then for message systems like Kafka, you typically have it set up as brokers, where brokers can like store data for multiple queues like topics and partitions. And then there can be multiple publishers, multiple subscribers. Brokers also track what are subscribers reading, what are their offsets, and it gets closer to like offering trade-offs between at most once, at least once, or exactly once. Like for example, depending how you commit offset, like when do you commit it, like is it immediately after reading or like after you confirm that everything was processed? You can get at least once or at most once. Exactly once is like pretty difficult. Usually it's done combination of at most once and at least once, but it usually makes the system like really like tough, and you need to sacrifice quite a lot for that. Let's take a look at simple in-memory queues. Good for messages being short-lived and acceptable to lose them or have some delay during restoration if there is an outage. You can just have some synchronized queue, maybe some disk or object storage backup, as I mentioned. And like if we can remove messages after consuming it. And yeah, that's just about it. I think if like expected lifetime is like maybe like a couple of seconds, it's consumed immediately, or maybe like several minutes if there is some backlog, then it can work pretty well, and you don't need to overcomplicate it. We also may sometimes skip a backup if it's okay to lose data, but generally backup's a good idea. Redis pub/sub. So Redis has this pub/sub, which I briefly talked about. Yeah, so pretty much like it introduces this concept of named channels, or like similar to like named topics. So publishers can publish to like one or multiple topics, but usually like for given message it only goes to one topic. But then like subscribers can read from the topic. And in this case for Redis, it's important that like who is subscribed gets a message, but then the message gets deleted. So it's very scalable and a good choice for low durability requirements. So brokers, their components can send message in persistent manner. So there's like replication. Yeah, we store messages into like topics, which may be partitioned. Partitions would have replication. Then there is like some broker leader election as well. To achieve high throughput, database may not be good enough. So like write ahead log directly to disk can be used. It's basically we write to disk in chunks and store some locations where it's written, and some maybe files, and like maybe we can do some batching so that there are not too many files and inodes are not getting overused. And then disks are good actually for sequential reads and writes and have like much higher throughput than for like random ones. And then we can have some cleanup jobs, which like after the messages get deleted, they clean up the files, like do some defragmentation if needed. The brokers can also store offsets at which different subscribers are currently reading the messages. And yeah, depending on like at the most once or at least once, we commit on like in different places in the code that we like read some messages. Messages themselves can have expiration, either be removed by a background thread or marked as stale and then later cleaned up. Or then maybe they're removed immediately. All of it has like upsides and downsides in terms of speed and then like reliability. Overall, thanks for watching. It's been like a relatively short overview. There is a lot more I can talk about, like systems like Kafka. But yeah, some key things is like use write ahead log. Think about at least once and at most once delivery in the process of how you like structure reads. Then think of some like replication, and those are some main things. Thanks.